Hello all, welcome to Dam Engineering channel. In this video we will learn about the components of dam and various terms related to dam. In the pictures shown here, we can observe that all the three dams are not same type. Their length, layout and components are different. Selection of type of dam depends on many factors. Topographical factors, geological factors, design, flood and seismic hazard and so on all decide the selection of a particular type of dam. We will see one by one. Here we see both images representing a earthen or rock-fill dam. Both dams, we can see the difference in layout. Left image earthen dam is lengthwise is less. Right side dam length is more. Dam layouts differ from project to project based on site conditions. Generally earthen or rock-fill dams are economical when dam length is more. Further, concrete dam requires strong rock as foundation. Whereas, earthen dams, strong foundation requirement condition is not mandatory. Further incoming design flood is less, then also we can have earthen dam type to optimize further. We all know the types of spillways and more the incoming design flood, more is the spillway width. Now we see terms and components of earthen or rock-fill dam. Once the dam is constructed, reservoir is formed. We are seeing downstream slope. We are also seeing spillway that is chute spillway. Left side is steep hills, so spillway is located or it is part of dam abutment. Right side dam is different, that is dam is separate and spillway is constructed on right side hills based on the site conditions. Further, if we see in detail, cross-section of dam. There are mostly 4 different types of earthen dam. Those are without core, with core and upstream inclined core and upstream membrane type of earthen dams. Here, we can see in the dam cross-section, at the center we have clay core which is surrounded by coarse material. For earthen dams this will be suitable soil. For the dam image we are seeing on the left side, this will be rock-fill material, that is little big size rocks of suitable sizes are placed. Both these coarse materials are covered by rip-rap material. This will be further bigger than the coarser material. Purpose of rip-rap is to protect the dam from erosion due to reservoir water on the upstream and any rainfall or other conditions at the downstream end. As already discussed, hard rock is not mandatory for earthen or rock-fill dams. These dams can be placed on weathered rock or suitable strength of overburden. The important criteria is here to check the seepage beneath the dam. If we are placing the dam on weathered rock, obviously there will be some seepage. To control the seepage, there should be some grouting. This grouting is called as curtain grouting. Further, gradation of different materials in earthen dams is highly required so that the particle size increase shall be uniform. To collect the seepage and also to match the gradation, filters are proposed. Once the seepage, if any, is collected through sand filters, it is drained or collected at the downstream using rock toe at the downstream. Now we will learn about concrete dams. Here we see 2 different concrete dams with different layouts. We all know dams are built for many uses. One of the important use is generating hydropower. Based on the width between 2 abutments of river, the length of dam is fixed. Narrow gorge will be highly preferable. But if we do not get that also, we can have increased length of dams. Now we see the different terms of concrete dams. Once the dam is completed, reservoir if formed. In the concrete dam, length is divided into different blocks. Earthen dams are placed and rolled in layers, whereas, concrete dam is divided into different blocks and each block width generally limited to maximum 20 meters. Each block is constructed separately. That is the reason we are seeing overflow block and non-overflow block term in the pictures. Overflow block means spillway blocks, that is we allow water to flow over blocks. For every dam, whether it is earthen dam or concrete dam, spillway is must to pass the incoming floods. These blocks are called as overflow blocks. Other blocks in which flow is not allowed are called as non-overflow blocks. In short, we call them as NOF. In both the pictures we see there is a powerhouse to generate the electricity. These type of powerhouses are called dam toe powerhouse. Because they are just at the toe of the dam. We can appreciate here that why at this place concrete dam is preferred over earthen dam. Because spillway is must and also to have space for powerhouse, it is difficult to place the concrete spillway and concrete powerhouse in the space available. The width left after concrete spillway and concrete powerhouse will be less, and placing earthen dam along with its connection with concrete dam will be difficult. Hence, for the above locations, concrete dams are preferred. Now we see further details of concrete dams. Here we see the sections of different blocks. Here we see the 3 blocks sections. Those are dam toe powerhouse block, non-overflow block and overflow block. In the overflow block as shown here we will have hydro-mechanical, that is gates will be present. In additional to gates we will have energy dissipation arrangement, that is either stilling basin or bucket type arrangement will be present. These two are the major difference between NOF and OV. Further, if we see dam toe powerhouse, the section we can see has conduit for passing the flow to turbine which will generate electricity. This is how we develop different sections and different blocks and planning accordingly. If we see further detail of overflow block here, we can see gates and stilling basin here. Gates are to open and allow the water whenever there is need to pass the flow. This water when comes down has so much energy which needs to be dissipated. That is the reason stilling basin is given based on hydraulic jump. Further, as we have seen in earthen dam, to stop the seepage we have curtain grouting. Here also we will have to grout the foundation below the dam to stop the seepage. This will be done using gallery which are opening in dam body. Further, if any water or seepage is present after curtain grouting, that will be collected in gallery using drainage holes. The water collected will be diverted to downstream of dam using sump arrangement. This is how we plan the dams and also decide type of dam. Thank you.